And let's just, oh, enter. Sorry, is that okay, Boris, or?
I think you just
oh, perfect. Oh, shoot. Okay, did not even see that. Wow, look at that. Where's it to? Hold on. It's actually not showing on the screen. Hold on. One sec. I'm just gonna unshow for a sec. Got it.
Yeah, good.
Cool.
Set.
Good to know. Okay, good to go. There we go.
Bingo.
All right, awesome. Ready, set, roll. So Boris, thank you so much for the warm introduction, and what a pleasure to be here with Tony. He's my advisor, so we're tag teaming the presentation.
Yeah.
Talking about plastic pollution in both the contexts of our work. Tony obviously has a leg up on me because he has many years of experience in this field and is quite the international leader with science policy. Hence why I came to Dalhousie to study with him, and also my co-advisor, Dr. Jenna Jumbeck. Just before we start off the presentation, I think it's always appropriate, we always hear terms like plastic and plastic pollution and trash and garbage float around every day in our lives. And I just want to ask the audience, what do you folks think when you hear the word plastic? What comes to mind? Because I mean, it's just such a versatile term, literally.
Long chain polymers that are used for all sorts of wonderful things.
Love presenting to environmental scientists.
Yeah. Bonus points.
Yeah. Anyone else? Wonderful. Oh my gosh, this is so much better than normally what we get. Styrofoam, takeout containers, stuff like that. So yeah, we have really technical terms. At the end of the day, plastic are synthetic.
Yeah. We're probably wearing them, we're stood on them, we're sat on them right now. So yeah.
Great intro to the presentation. So
an audience says fossil fuel.
oh, fossil fuel, right on. Yeah. Okay.
Yeah, that's right. Then we're going to get to that. So that's right. And so again, unless you've been living under a rock, which you haven't because you're well informed and you already know quite a lot, we're in the midst of a plastic pollution crisis. And like all wicked problems, they seem incredibly daunting, but there are solutions. And so that's what we're going to touch on. And so there's always hope. But why are we struggling now with our plastic pollution crisis? How did we get here? Well, it's in popular culture, it's widely used. So Dustin Hoffman in the film The Graduate in the 1960s didn't know what to do with his future. And a neighbor of his parents said, there's a great future in plastics. Fast forward to a recent film, which I've not seen, but thanks to freshening up the slide deck, Justine, we now know that life in plastic apparently is fantastic, but we beg to differ. We would argue that there's a great future in plastic alternatives and zero plastic waste, and we actually don't think life in plastic is fantastic, and we'll tell you a little bit more why. And the reason why that we're drowning in plastics, plastic use and convenience and all the rest of it, is it's really been pushed by fossil fuel industries and the plastic industries in our overconsumption. And going back to this 1950s ad, disposable items are really convenient. And that's what we've all bought into. And when you extrapolate that to 8 billion people, you can see why we've got a plot like this. So this goes back to, although plastics have been around and first invented in the late 1800s, mass production after the Second World War really took off in the 1950s. And this is where we had reliable data, reporting data on production. So from the 50s right up to the present day, we've had a 20-fold annual increase. So not annual increase, but a 20-fold increase. And although that plot from the Ellen MacArthur Foundation about 10 years ago reports 311 million metric tons, more recent data from Plastics Europe now puts us at close to or slightly above 400 million metric tons produced per year. And that doesn't even include textiles. So what does that look like in terms of plastics ever made since reliable data from the 1950 to 2015. This is a paper published by Roland Geyer and colleagues, including Jenna Jumbeck, on this particular life cycle assessment. And so at that time, global production total global production was estimated at 8.3 billion metric tons. It's actually close to 9 or slightly above 9 now. Most of that, a lot of that is still in use, like the synthetic paint on the walls, the carpet we stood on. These chairs look like they've been around for a while. So some things are still in use, and that's okay. This table, for example. However, the vast majority, about 40% of plastic items have been discarded after a single use because they're convenient. Think back to that 1950s ad promoting the use of disposable items. But can you see the how much we've recycled? Does anybody, I mean, it probably tells you there, but do you know what the current global recycling rate is as a percentage? Any guesses? 15 is quite optimistic. 10 is closer to the realistic value. So here in Canada, there was a study commissioned by Environment Climate Change Canada and Deloitte, and the estimate nationally here in Canada was 9 to 11%, depending on your jurisdiction. But globally, it's about 9% as well. So it's pretty pathetic. And so just to bring you up to speed and just the salient points, we've produced 9 billion metric tons of plastic, and most of that is now waste. At best, it's in landfill. At worst, it's in the environment. And you could argue that once it's in the landfill, it's still potentially leaching out, the chemicals leaching out in groundwater, as well as the microplastics as well. So 3/4 of it is already waste. We haven't done a very good job in the last 70 years, have we? And of course, that 9% recycling rate, that's still a questionable kind of estimate. It's very, it's not very transparent. And the reason why is because we're engaged in the global plastic waste trade. So we put out our blue bags, we do a good job, we pat ourselves on the back. Maybe we've washed out our peanut butter jar and it's clean and it goes in. Well done. However, it's not the end of the story. We might recycle some materials domestically here in Nova Scotia and elsewhere in Canada, but the majority has been exported to other countries for recycling. And that's part of the global plastic waste trade. As you can see from this plot, this is exports from Europe to Southeast Asian countries. And I don't know if you can see that the most of that up until 2018 was exported to China. And they did have reasonable capacity to handle global waste. But in 2018, the Chinese government decided to prohibit the imports of plastic waste as well as other materials and only recycling their own domestic waste. So that left the high-income countries like the US, Canada, Europe, and elsewhere scrambling for markets to export their recyclable materials. And as you can see, some of the other Southeast Asian countries picked up the slack, but they quickly became overwhelmed. And even some of those now have banned and prohibited imports because a lot of that was either commingled with other plastics. It was like multi-layered film. So it wasn't polymers that could be easily recycled, or in fact, it was contaminated because it wasn't even clean. So you've heard the story about baby diapers. So we've mentioned that the global plastic waste trade existed, and it still exists now, but it's been scrutinized by the amendments to the Basel Convention to hopefully clean up that this particular trade. But this is a plot and a paper published by Jenna Jembeck and colleagues in 2015, based on leakage data from 2010. And you can imagine that international and national reporting of waste or waste that we can't account for is, is ambiguous. And so this data from 2010 was prior to that import ban that China imposed in 2018. But you can see that most of the leakage on this plot, based on estimated data, and again, before the ban from China, it appears that most of the leakage is from China and other Southeast Asian countries. But that is incredibly unfair because it really doesn't take account. And by Jenna's own admission, it doesn't take account of the exports from high-income countries. So Canada looks pretty sweet and light and breezy on this image. So does the US, but that's because they were exporting to these countries that quickly became overwhelmed and couldn't really handle the waste. So one thing I forgot about Jenna's paper, one of the most impressive data points, which was used in many media outlets, was the leakage rate was estimated at 8 million metric tons. There was a wide error ranging from 4 to 12 million metric tons, but the number that most reporters and most studies have used since that paper came out was 8 million metric tons leaking into the world's oceans. Let's not forget that landlocked countries weren't accounted for in that model, nor was leakage from rivers. However, fast forward a few years, and some of the same authors, including Jenna and others, published another paper with a new data set with more reliable and robust reporting. And that estimate of 8 million metric tons of leakage, was staggering and daunting, was like a threefold underestimate. And so current estimates are between 19 to 23 million metric tons leaking into aquatic environments, both freshwater and marine. And that's astonishing. But let's not forget, if we don't do anything with our current mitigation strategies, that could quickly rise to 53 million metric tons by 2030. That's just less than 7 years from now. So what does that really mean for the environment and economic impacts? Well, plastic pollution is not just an aesthetic problem, like this image from a harbor in Southeast Asia. It actually costs us. And so this is a study from 2014. So the data and the financial estimate is probably a massive underestimate, but that's 13 billion US dollars per year to clean up that plastic waste, right? So think of that. It's a staggering number. That's what it's costing us. However, when you really take into account the losses from ecosystem services like degradation of mangroves and the productivity in carbon sequestration, the fact that you've got seabeds now smothered in abandoned fishing gear, that's actually preventing the ability for oceans to sequester carbon. It's removing habitat for fish. And Nicola Beaumont and colleagues in Marine Pollution Bulletin estimated it was costing society 2.5 trillion US per year. And so that's probably also an underestimate too, because it's considering marine impacts. What about terrestrial impacts? What about the loss of ecosystem services in terrestrial environments? So just think about that. So let's have a quick look, a 101 on what those plastics are. Macroplastics, again, it's not rocket science. You know what they are. You've seen the bags. We know they've been banned recently in some jurisdictions. But microplastics, although the scientific community argues about size classifications on certain small particles, microplastics is largely agreed upon by the community as being particles that are less than 5 millimeters, right? And so you can see the degraded particles, the secondary microplastics that have degraded from the macro, and then of course the intentionally made microbeads. And I didn't even know that was a thing until a decade ago. But in 1990, these microbeads were introduced into some of the products that we use: toothpaste, facial scrubs, soaps. I didn't even need them before 1990, but apparently after 1990, we needed them. And so they were added to many of our products. They've since been banned here in Canada and the US and Europe, but they're intentionally made primary microplastics. And then this category, the microfibers, keeps me awake at night. So think carefully about the clothing and the floor coverings we use moving forward. And so, yeah, there's the citation for that. Am I going to talk about this one and then hand over to you? Is that right?
Oh, yeah.
Yes.
Go for it, Tony.
We already had some great answers from the audience, including our online audience, of what plastics really are. And so you can see many of these products. These are the convenient items we use on a daily basis. We can't avoid them. Yeah. And if we look to the items there and the polymers on your right, no, your left, so these like PET, they're the plastic bottles. These are the things that can be readily recycled, and they have relatively high after market value in the global plastic waste trade. And similarly with HDPE, and then if we move across this chart here, as we move across to expanded polystyrene, it's convenient, it's light, it's widely used, but it's very rarely capable of being recycled. Despite the fact that it boasts a resin code, it's like having a license to hunt, but no guarantee of prey, which means we probably can't recycle that because it's such low value in the aftermarket world.
Perfect. So now that we've talked about different chemical compositions that the plastic family can be made up of, diving more into the term microplastics, similar to how we started off the presentation with asking you what you thought plastic is, this is a really loaded term. Microplastics is being used in a lot of different contexts to describe really small pieces of plastic. But in our opinion, I mean, and we regularly talk about it, it doesn't do justice to the umbrella that's underneath what microplastics actually are. The fact that Tony touched on the different types of chemicals that can make up plastic is one aspect that, makes up what a microplastic is, but also its shape, size, color, different morphology, how long it's been in the environment, how much it's degraded. And a really excellent paper that dives into this really theoretical question, what a microplastic is. Was done by Chelsea Rockman over at the University of Toronto. And there's this brilliant line that Tony thought it was a statement of just a mistake where it was just being repeated, but she puts in her paper where it states microplastics are not microplastics are not microplastics, just like how pesticides are not pesticides are not pesticides. And I think that repetition really drives home the point in that we really have to think about these terms before we start throwing them out. And dive into the complexity that lays behind them. So just to kind of put in perspective, the issue of microplastic pollution and how it exists in biological compartments, we're not only faced with this really complex type of contaminant, but it basically changes over time. It changes according to production scales with different companies and what kind of chemicals they're putting out. And it's just really difficult to kind of keep track on, how to mitigate this type of contaminant when it's always evolving. So this is a really interesting image when we think about plastic pollution. Images like this often come to mind, beaches just ladled with macroplastics and big pieces. But oftentimes when we look at landscapes like this, we're freed from those really prominent pieces of garbage. And, we see snow, we see ice, and we think it's pristine, it's clean, it's untouched. And in actuality, microplastics have been found literally in all corners of the planet. At this point, there was a study done in Antarctica, way deep into the continent, showing microplastic presence in the ice cores and on the surface levels of snow, as well as the deep sea. So even though we see landscapes like this throughout our planet, we always have to be cognizant that this is a very quickly evolving chemical, and it's really capable of traveling far because plastic was really designed to be lightweight. And given the fact that it fragments over time, it's a perfect candidate to really go without a passport anywhere on the planet. And that kind of brings us to one point that unfortunately I've burst a lot of bubbles over the past month or past year, especially as I started my PhD and I've been focusing on atmospheric microplastic pollution, is that this is really exciting time because in the past few years, our colleague Dr. D. Allen and Dr. Steve Allen have published quite a bit of literature on the movement of plastic through air currents. And, this quote unquote new frontier, for lack of a better word, in which plastic can travel and really distribute and surpass these trends that are these global boundaries. So this, even though it's not directly related to the marine landscape in, ocean currents or surface waters, through Dee's work, there's been a lot of evidence to suggest cycling between air currents and surface waters in that plastic can move through these different media. So looking at how plastics can implicate marine life, I just want to draw attention. There's a lot of pictures we could have shown you in this presentation, and I think Tony and I have kind of seen quite a bit through our careers with animals being entangled and impacted by plastic pollution. But just to kind of give you a poetic stance on, just how far this problem has gone on. The latter image really stood out to me about 7 years ago when I was reading through the literature, and I found out that there was a sperm whale that was described washed up on the coast of Granada, Spain. And when the biologists basically checked inside its GI tract, they found the contents of a literal greenhouse inside of it. There were like landscape tarps and flower pots and shovels, like the handles from it, and it was all inside its gut. And for me, I mean, growing up in the city of Toronto, where my dad has works in the greenhouse industry, as he sells trees, this one kind of hit a nerve because it combined both of those worlds together, where, you know, it brought in what my family does all through beautiful animals like sperm whales. So it just really exaggerates, or it's an exaggerated story to show you just how bad it is. And of course, being biologists in the room, you know that plastic can impact animals through different ways of interactions, including ingestion, like the whale, entanglements, habitat damage. You can get fishing nets smothering the seabed floor and therefore impacting like sessile marine organisms, and also introducing non-native species. So the question is that, you know, a lot of species around the world are being impacted by plastic pollution, but who's keeping track of all this? And lucky for us, there's a lot of dedicated folks in our fields who kind of take on that emotional labor of tracking, you know, just how bad this problem is. So for example, within the publication world, Dr. Melanie Bergman at the Alfred Wagner Institute, are both of our colleagues, and actually my supervisory committee member, started an initiative called LitterBase. And this is an amazing resource if anyone's interested in just learning how diverse the impacts of plastic pollution are on wildlife, because every time there's a publication, that data gets pulled in and all the species get recorded. And, you know, just all the details basically that describe how those animals are interacting with plastic all get put into the database and then shown in various different ways. Also, you can see this was the current count as of 5 a.m. this morning, which was just over 4,000 species have been recorded to interact with plastic. That's within the marine environment. In terms of citizen scientists, just to take a pulse check, how many people are familiar with that term? Citizen science, awesome. Okay, for those of you who haven't heard it, basically this idea that anybody can be a scientist. You know, if you have this driving curiosity about the outside world, you can ask questions and you're interested in understanding how things work, really lead you to be a scientist. And this whole initiative of citizen science has been really big in the past few years with engaging the general public in these really stringent and strong citizen science programs. So bringing it back to plastic, there's one initiative called Birds and Debris, which is actually, I think, rebranding to be Animals and Debris, because they've gone beyond just the scope of our feathered friends. And this was started by Dr. James Neal and Dr. Nina O'Halloran, colleagues of one. And what's amazing about this database is it relies on images and photos. So anybody can take a photo with their camera these days with their little phone, and basically just upload it to an online database where you can keep track of how birds right now, but actually more animals down the line, are interacting with debris, whether or not they're incorporating debris into their nests, if they're carrying it back for their young, if they get entangled in it. So these are really important databases and ways to keep track of just the impact of plastic pollution. Thinking about microplastics and kind of ruminating on what I mentioned just about how complex they are. You know, we're not dealing with any ordinary contaminant like mercury or arsenic or heavy metals, where it's a little arguably easier to measure the intensity of those loads. You know, microplastics have been extensively found to interact with wildlife through kind of more the macro level forms of interaction. So that's ingestion, inhalation, and excretion. But all these other components, bioaccumulation, trophic transfer, biomagnification, and bioconcentration, require a little more complexity in terms of how we study them. And unfortunately, you know, when we do a lot of ecotoxicology studies in the lab, a lot of folks have been really quick to jump on the microplastic bandwagon and, you know, get experiments started and trying to understand just how bad the problem is without getting a sense for what the actual environmental conditions are in nature. And unfortunately, it's been really hard to mimic these kinds of interactions because they're really hard to replicate in a lab. And this kind of pulls into one study that was published in 2020 by Busey and al., also one of Chelsea's students. And basically in this meta-analysis, they looked at over 150 ecotoxicology studies in looking at just what kind of impact microplastic exposure has on animals. And what they ended up finding was really interesting. They found that 17% of the studies were basically, they used experimental conditions that were found in nature, leaving almost 80% of the other remaining studies kind of being more exaggerated in different forms. And that was either from not using microplastics that were appropriate sizes of what were in nature, or, the actual concentrations. And just to pull your attention to this figure on your left, you can see the various types of ways researchers have studied microplastics. And it can be on really small scales, from subatomical all the way up to ecosystem level effects. And as you look at those two extremes, going from really small to really big, you see fewer studies being able to replicate those conditions. And that just speaks to how complex this topic is, especially when you're trying to mimic it within lab settings. I'm still going on this one, right, Tony? Yeah, okay. So really, microplastics have been around since the 1960s, and plastic pollution. This isn't really a new issue that we're facing. Researchers in Newfoundland were writing about how seagulls were eating discarded tampons in the garbage dumps back in, I think, 62. So it's one of those topics where, as gory and gruesome as it sounds, I mean, it's been on a lot of biologists' radars for decades. But we didn't really hear about microplastic and plastic pollution in the mainstream until about 2010, 2016, really, when it peaked. As soon as David Attenborough started picking up trash on the beaches around one of the sites they were filming at, and that was caught on camera, there was something called the Blue Planet effect, in which because David Attenborough was doing it, it was now cool, and people started really tracking onto this idea of cleaning up beaches and trying to understand just how much garbage is in the environment. And this was really heightened by National Geographic's publication as well. I don't know, have a lot of people seen this cover before? I'm getting some nods. So yeah, it's supposed to be an artistic take on an iceberg, but it's a single-use plastic bag. And this issue actually gained quite a bit of traction, and led to a lot of smaller organizations popping up in this coordinated effort to really tackle the plastic pollution problem. So the question I guess we're left with is, what's the most effective solution for plastic pollution? Now that we've depressed you and we've told you all about the doom and gloom regarding human society and the environment, posing the question to you folks, what do you think the best solution for this is? Thank you. Okay. There's no point with this audience. You guys just get to you get down the rabbit hole pretty quickly. Yeah, basically making less stuff and using less stuff and throwing out less stuff. And turning off the taps is the most effective way at addressing plastic pollution. But I'm sure most of you know, because we're all consumers at the end of the day, we have to unfortunately live in a coordinated society, and we can't just run off in the woods or off to Sable Island. Basically, a lot of companies are kind of going down this route of greenwashing their products with saying that they use less plastic in their packaging, and they're really trying to cut it back. When in actuality, sometimes we don't need single-use plastic straws or spoons, cutlery, things like that. So I'll hand that off to Tony.
Right, so
responsibility.
that's right, and we are actually going to chat about that. Yeah. So yeah, turning off the tap. So for example, if you did have a tap in your bathroom and it was flooding, you don't go around mopping it up. You turn off the tap first, then sure, go and clean up the residual on the floor. And so that's the same analogy with capping the production, which is already 400 million metric tons globally per year. We need to reduce that. We need to consume less, and we need to start reusing things that we already have. Limited resources, right? And so there are some solutions already out there, and I'll get to the current ongoing plastics treaty negotiations right now. But even way back in 2018, when Canada was held the presidency of the G7, we announced the Plastics Oceans Charter. It was a 4-page lofty document, which also included extended producer responsibility on the 4th page. And then we have other national and regional initiatives to curb pollution and to actually, basically increase awareness, but also making sure that governments at the national and international level are recognizing this plastic pollution problem, which we're already doing. And look, even the UN Sustainable Development Goals have addressed it, but only in one of the 17 goals, and not one single mention of microplastics pollution. And we still haven't figured out an international standardized way of monitoring and tracking our reduction strategies, but that's the next step. So What solutions? Here in Nova Scotia, we know we have a plastic bag ban. So there are combinations of government legislation. There's market-based initiatives, like in the UK, they introduced a small tax and cost to buy a bag. So people didn't want to spend 5 pence on that plastic bag. They decided to do away with it altogether. So there's like levies, there's taxes, there's incentives, there's market-based strategies. I'm not sure if EPR is on here, but you can, yes, it is, EPR. The province of Nova Scotia, if you didn't already know, is going to be soon implementing an EPR strategy. Several other provinces in Canada have them, but we don't have a harmonized one nationally. In fact, one of my former MES students helped guide the policy for that EPR strategy. So watch this space. And as we move down this column, you can see all of these solutions are great, but there's no one silver bullet. And they seem to be done in a kind of a mismatched, uncoordinated way. However, until now, we have the current ongoing plastics treaty negotiations. The next meeting is in Nairobi, and the meeting after that, because it's going to take 2 years to decide as an international community what we're doing to address this. And of course, as you can imagine, industry does not want to cap production because it's going to hurt their bottom line. So again, watch that space for a legally binding agreement. And so, you know, there are good role models out there, and countries which are really have stringent management policies for plastic waste. Other countries, you know, have mismanagement, and of course, hence the leakage. But Norway, for example, they have a deposit return scheme. So, you know, you're already paying a deposit on whatever item, and in this case, it's plastic bottles. But in order to get that cash back, you return the thing. So basically, it means that very little leaks, very little ends up in the environment, and it promotes a return-based economy. And in fact, of the 97 plastic bottles returned, most of them are recycled again. However, that's not the kind of like, it's not the ultimate strategy, because sometimes even with PET bottles, they're only recycled for a number of times before you start to degrade the polymer structures, as you probably already know. So this is what the landscape looked like prior to COVID. A mismatch, a patchwork of plastic bag policies to reduce single-use plastics, a combination of taxes, combination of outright bans. Outright bans was very popular and still currently is in Africa, very stringent. But really it just shows and highlights that international and national governments, because there's regional provinces in there, Nova Scotia being one, there's an appetite to reduce plastic pollution. But again, it's the tip of the iceberg. And if we look, this is a student of mine from a couple of years ago in the MREM program. We did a review of all the different regional and national strategies to reduce plastic bags and also those microbeads. And even as early as the 1990s, countries like Germany and Denmark and other European countries were banning plastic bags already. But it wasn't that kind of momentum rapidly increased in the last few years, probably also spurred on by those Blue Planet effects and that public outreach. And more recently, microbeads have been recognized and targeted by governments for legal bans. Here we are, little old Nova Scotia, second province in Canada to implement a single-use plastic bag ban. And that was during COVID, but still that was pushed through, and it was largely successful. And overnight, it pretty much eliminated many plastic bags in the waste stream. However, that's not without industry pushback. And this chap, Joe Haruska, the then vice president of sustainability for the Canadian plastics industry, he was my nemesis. As we were putting forward and helping the government with these policies, he was saying that, hey, single-use plastic bags, they're really good for the environment because the alternatives, like paper, which is slightly true in terms of the environmental footprint of making a paper bag simply to replace a single-use plastic bag does have a higher carbon footprint. However, what his model and what his studies cited does not take account the full life cycle of plastics, from the fossil fuel extraction to the end of life where it ends up in a landfill or a open burning pit somewhere, releasing dioxins and greenhouse. So when you factor in the full life cycle of plastic bags, then the argument is slightly different. However, the argument for reducing single-use plastic bags isn't to simply go and switch to another disposable item, is to do with that use reusable. And I think that's where this was often overlooked by the industry pushing back. And so the Canadian government has also recognized this. And again, many of you will already know that the Canadian federal government has announced a ban on several types of 6 types of single-use plastics. I think there's 6 types. And the first wave of that phased approach came in December 22. But how do you check that government policy is effective? You need to measure. You need to measure before, you need to measure during, and you need to measure after that policy. And this is where research and evidence-based approaches are required.
Perfect. Thank you, Tony. And yeah, just kind of reflecting on that, I think Tony and I work well together because we kind of get underneath the government's skin a little with trying to figure out empirical evidence behind these policies. How do we actually test if they're effective? And like Tony mentioned, this ban was started last year in December of 2022, and 6 different items were targeted. And to be honest with you, we can have a whole discussion on whether or not we think this is the right approach, because obviously plastic is complex and it's not just limited to straws and bags, but it's a starting point in Canada, which kind of makes a firm statement by banning a community of different types of single-use plastics. So basically the work that with the government's move towards this policy, they're hoping that it's going to eliminate 1.3 million tons of waste over the next decade, which is a substantial amount. But realistically speaking, it's not going to solve our plastic problem. What it's going to do is raise attention to the issue and get people mobilized in a way that gets them to think outside the box, both from the consumer aspect, the distributor, as well as the retailers and inventors. So part of my thesis for my PhD, I'm looking at the effectiveness of these bans and seeing whether or not they actually work. So last year, I worked with my co-advisor, Dr. Jenna Jumbeck, on adapting her protocol that she developed called the Circulatory Assessment Protocol. And if you think of this as kind of like an ecosystem, animal community thing, more from a biology aspect, and then translate it into this weird mashup of civil engineering, social science, and also geospatial mapping. That's basically what this protocol is. And it's looking at the movement and life cycle of plastics right from the start, from where it's coming from with the producers, straight through where the distributors are, so retailers, shops, etc., that give away single-use plastics, and then looking at plastic as it moves through the system. How do people use it? Do they accidentally lose it on their way to work? Do they mismanage it and litter it on the ground? Or does it spill out of waste collection sites? And you kind of follow this life cycle of plastics until you paint a holistic picture of what a municipal plastic landscape looks like. And surprisingly, a lot of communities around the world have annual audits being done on litter landscapes. There's usually in Canada, third-party environmental consulting companies that will go in and paint, what kind of items are on the ground and putting together these distribution charts. But in those circumstances, from at least what I've been able to see, has anyone really dove into the problem, where it's looking from the start to the end and everything in between? So that's where my research is kind of filling in the gaps. And as I mentioned, this was developed by Dr. Jumbeck's lab. So this framework's actually being used all over the world. It's being used quite a bit in India with her collaborators on the Ganges River expedition, where she applied it, and then throughout the United States. And last year, I started my field work by getting that nice before snapshot of what the litter landscape looked like around Halifax and Dartmouth. So just to show you an example, there's a grid that's applied over the city. It looks at population distribution and population density. And it also takes into account through algorithms, how many retailers are in the location, how much traffic is there, et cetera. And essentially what you're left with is going down streets, picking up different forms of litter, painting what that debris landscape looks like, going like a crazy person, quite frankly, up to garbage cans and taking your phone and taking shots of, what's being collected, and also going into retail shops and taking an inventory of the different types of single-use plastic there. And by basically putting together this database, we can see whether or not these policies will actually make an empirical difference down the line. And at least we have a baseline to work off of. So working on this idea of how we're going to solve the plastic problem, citizen science is definitely one aspect that can really help. And that's just because with the engagement of the general public, you can collect a lot of data very quickly and also get people excited about environmental issues that normally they might not have access to, especially if they're not in a university or scientists themselves. So looking at this idea of debris landscapes, with the single-use plastic ban that was implemented by the government of Canada, they actually based their selection of those items from these folks here over at Oceanwise. If the name doesn't ring a bell, it's an organization within the Vancouver Aquarium. And for over 30 years, they've been running something called the Great Canadian Shoreline Cleanup. And they've been amassing citizen science data for decades. And basically, when the government was picking which items they wanted to ban, they looked to the citizen science data. So it can show that, this kind of contribution can actually make a huge difference. Just to kind of highlight some of the dirty dozen that they normally highlight every year, think of it like the Oscar list, but for trash. Cigarette butts are usually almost always number one, just because it's literally the most littered item in the world. And then thinking that this is 1 year into the pandemic, PPE, personal protective equipment, already started to debut on the list, not only in 2021, but actually in 2020. So citizen science data sets are actually really important to identify debris hotspots and where we can make the most impactful changes, looking at where debris is leaking out from use and mismanaged into the environment. And it's really important because it can help us intervene in this pathway. So Tony, this is...
I'm on again, am I? Crikey,
Yeah.
Excellent. Okay, so at the kickoff for the pandemic. And so what we've been doing and what Justine's already highlighted with our, buying a convenient item, it's got wrapped in plastic, it ends up in the trash. So we've got this take, make, waste economy, and we need to get into a circular economy. Obviously, that transition is going to take time. It doesn't happen overnight, but that's the way we need to get. And of course, the Helen MacArthur Foundation, Helen MacArthur, if you didn't already know, solo yachtswoman, sailed around the world at least a couple of times. And so as I was a teenager growing up, she'd already made these big achievements, but passed through the ocean gyres where you've got these large accumulations of plastic. And so she set up the Helen MacArthur Foundation to develop this future economy where we reduce our use, but also waste less and reuse. Many of these international organizations have already signed up to be part of this. But remember, this was from announced in 2018, and they want to incorporate that much 100% reusable or recyclable or compostable packaging by, a couple of years from now. It's unlikely because we're not even close yet. And some of these big organizations, Unilever, Pepsi, and Coca-Cola, they're some of the most popular branded items found on beaches around the world. So we still have a long way to go. I already mentioned at the beginning of the presentation that we're in the midst of a crisis, a global crisis. And much like other global crises, it's not a separate crisis. They're all intrinsically linked. Fossil fuel, 99% of the plastics we currently use are made from fossil fuels, and only a tiny fraction, depending on the study you use, is 1 to 2% of bio-based stuff. And at the end of life, when it's like waste to energy programs, which is considered an afterlife treatment, it's still producing greenhouse gases, even if we have a precipitator on those chimneys. And there are even well-known scientists around the world debating and arguing whether we should not concentrate on plastic pollution. Let's focus on climate change first. But we argued in our rebuttal to a similar article that you can't treat one crisis in isolation. They've got to tackle these simultaneously because they are intrinsically linked. Of course, plastic pollution is contributing to biodiversity loss, as we've already seen from those 4,000 odd species that are impacted. So we need to make sure that you've got to tackle all of them head on. And the reason why is because we're not going to implement our sustainable development goals if we focus only in our silos and only on one problem at a time. And this paper that I did a couple of years ago really just highlight that plastic pollution is only addressed in one of the 17 goals, and microplastics isn't even on the list. So we have a long way to go to make sure that we're implementing microplastics in our food systems. Well, that's really not helping with food security. Microplastics in water, well, it's certainly not helping with our drinking water, and certainly plastics in general is really emphasizing our overconsumption. So it's really not addressing so many of those goals. Going back to turning off the tap, it's obviously a very ambitious solution, but there's no one silver bullet for this. So we have to consider turning off the tap and using less. And myself and other international scientists published a letter which did have impact. But anyway, it's getting the attention of the delegates in the Plastics Treaty to make sure we do turn off the tap. Otherwise, we're in trouble. So, oh yes, that's right. And we did a similar pithy article, a couple of 100 words, but we have to make sure that this international legally binding agreement isn't just like the Paris Agreement, where every country says, yeah, we'll try and meet those targets. But then when they don't, like the US, for example, what are the consequences? There are no consequences. And of course, the US wanted to push for a low ambitious plastics treaty, much like the Paris Agreement, but we argue that it should be legally binding. Otherwise, it just will not work. And then where will we be? Fast forward to just last month, this document came out. It's called the Zero draft of the Plastics Treaty. And after the first two meetings during the 2-year period, INC 1 and INC 2, we now have these major items, including your extended producer responsibility on this list, that we need to now find out what's the meat and potatoes onto this draft outline. And that's currently being negotiated right now. I know we're pushed for time, aren't we, Boris? How long have we got? 5 more minutes. Okay. So do we clean it up? Remember turning off the tap. That's very important. Yes, but there's a legacy of pollution out there. And there's so many ambitious solutions already out there. You've probably heard of the global oceans, the ocean cleanup program. However, that's just almost as bad as the plastic entangling the organisms in the first place. So just going out and running around collecting stuff, especially when it's automated, could actually have unintended consequences. And we argue this in a recent paper with our colleagues. And so whilst there are many solutions out there, they're not tried and tested. They're unregulated, and nobody's really checking to see what unintended harm it is having to wildlife in the system. So we argued that these should be carefully considered in the Plastics Treaty, that yes, we do need cleanup technologies, but we have to make sure we're not also causing harm in the environment. And this goes to hand over to you now, Justine.
Perfect. I think this is the last baton switch for now, but yeah, essentially just to build on what Tony mentioned with the Ocean Cleanup Project. Has anyone heard about that initiative? Okay, so we kind of get the gist. We're going to clean up the oceans by putting a big plastic boon in there and basically dragging it alongside, and not just any part of the ocean, specifically the Great Garbage Patch in the Pacific Ocean. And this initiative was started in the around 2014, 2015-ish. And essentially what ended up happening a year ago, I don't know if any folks followed this, but the organization let out some pictures of this massive haul that they did. They cleaned up the ocean and they found over 3,000 pounds of garbage that was really clean. And it was really interesting because immediately scientists from all over the world started chiming in saying that those pieces of plastics look too suspiciously clean, that there's no way that massive pieces would have been intact like that, just floating around in the Great Pacific Garbage Patch, because most of them break down into microplastics and nanoplastics. So they ended up getting a lot of flack. So that's an example of how not really to do cleanups. You have to have ethics, of course, and not get in it for the donations. And obviously testing your technologies is really critical. There's one initiative that's been around since 2014 called Mr. Trash Wheel. And this is a perfect example of what a trash inceptor looks like. You don't just clean up the ocean, at any given point where you can get wildlife entanglements, but rather you target really dirty areas and you pick up the trash in areas where you know it's coming from. And they do it through a really creative way. They basically made a trash inceptor with googly eyes on top, and this caught the attention of the public. And Mr. Trash Wheel has a whole family. He's on social media. There's Captain Trash Wheel for gender non-binary folks. And it's a really great way of engaging with the public and also doing good science by, you know, reporting your results and keeping people engaged in the initiative. Similar initiatives are being done with sea bins at the Harbourfront in Toronto. And another way of incepting plastic pollution from its source is actually directly in your laundry room. So with your washer and dryer, our colleagues at over in the UK, Dr. Emma Jean Napper, did studies on how many plastics are shed every time you do a round of laundry. And essentially, there's solutions where you can basically put a filter inside your washing machine that captures all that. And that work was done by Dr. Lisa Erdel at University of Toronto. So just building really quickly on this point is there's no one silver bullet, as Tony mentioned, to plastic pollution. There's many different solutions that can be implemented. And do we have time for the quick case study, COVID? I wonder if we can. Okay, you know what, why not? We'll throw it in there. Sorry, folks, we're keeping you hostage. But so basically that's that covers, you know, how we can address plastic pollution mitigation. But, you know, looking at the COVID-19 pandemic was a perfect illustration of just how quickly some of those values go out the window when there's a public health crisis. And as most of you know, there was a lot of buildup with policy and really like big actions with reducing plastic pollution. But as soon as there was a disease, basically here comes on the single-use plastic masks and gloves. And early on in the pandemic, Tony was actually really the first person to report a global figure on just how many gloves and masks were being used. And every month, sorry, Tony, I'm stealing you're on that.
You should go with it.
It's stealing it, yeah. But basically 129 billion masks were being used every month and 69 billion gloves. And that was a very conservative estimate. That doesn't even account for all the additional forms of PPE like disinfectant wipes and the boots or the covers for your shoe covers, hair nets, things like that. So there was a lot of plastic being used. During this period, though, I was actually stuck in Toronto with my partner back at my parents' house. And what we decided to do was apply our knowledge of marine debris shoreline cleanups and treat our city like we would any coastal beach in Newfoundland where we previously lived. And what we decided to do was test the distribution of where all this pollution was ending up. So we looked at different survey sites all throughout the city, ranging from recreational trails right through the hospital district in the heart of downtown Toronto. And what was incredible about this project was the fact we were able to map plastic pollution throughout the city and find out where those hotspots were so that we could draw attention towards intervention strategies. And just having figures like this made it so much easier talking with policymakers that were local within our area because they were able to relate to it and really see the science happen before their eyes. And again, with the publication, we were able to do a lot more outreach, which was lovely because, yeah, it really brought attention to how you could spend your time in the pandemic. We were fairly privileged in that we weren't essential workers at the time, but we wanted to contribute as much as we can, at least with the environmental picture. Thinking about this idea of, you know, how the broader public can engage in projects like this was something Tony and I it was our first collaboration. I think we took each other for an academic test run before I signed on for a PhD and you signed on for
that
me.
was still a little bit COVID times.
Yeah,
wasn't it,
this was, yeah. So we explored citizen science and how it can play an especially important role in periods of public disturbance like the pandemic. Even just testing that project a little more, I started a side collaboration with some of my colleagues in the UK, the ones that started the Birds and Debris database. And we basically wanted to engage with citizen scientists to look at specifically how wildlife was being impacted by the pandemic. And this brought me more or less back to my biology roots because I really missed animals after looking at like trash and garbage and synthetics for so many years. So we hit social media, and because we weren't allowed to socially engage with anyone, we combed Facebook, Twitter, Instagram, Reddit, all these different types of platforms to see what people were seeing in their backyards. And it was astounding with what we saw. We found over about 120 cases of wildlife interactions with pandemic related pollution, ranging from face masks. I don't know if you can see over here, this is a reusable face mask of a man's face smoking a cigar. And that was observed over in Germany during surveys for birds. And up here with the swan that was taken over in Italy, another one in Singapore. So the global reach of what we were able to do as citizen scientists through the digital world was outstanding, especially since, you know, social media is a place of doom and gloom these days. It shows that you can actually use it for good, to bring attention. But anyways, folks, we want to thank you so much for your time and attention with everything. And yeah, it was a pleasure.
Thank you.
Mm.